everyone. Welcome to my class. I'm your teacher, Madam Kong. Today we are going to discuss about past year chapter 2.1. Are you ready? Let's start.
Okay, so good morning class. I think this is the last final week for us to continue with chapter 2. Next week we are going to discuss chapter 3. Yeah? So both atomic model, quantum mechanic model, electronic configuration. I think all of you already know what is this. Okay, for both atomic model, right? First of all, you must know there are how many postulate? How many Bohr's postulate?
4.
4, yes. Okay. Actually, right, the 4 postulate also help you to answer the question, right? How to form the line spectrum as well. So you must know, okay, at ordinary condition, the electron is at the ground state or lowest energy level. So when energy is supplied, right, so it will absorb and promote it to from a lower energy level to a higher energy level. So over here, right, the electron is excited. Okay, so this is the basic concept. Okay, so start. Okay, there are one. Okay, unstable. Okay, sorry. Just now this is the first one. First one's flow is here. Okay, electron move in a circular pathway around the nucleus. Okay, if there is nothing, right? Okay, it wouldn't be does not radiate or absorb any energy and so on. So I think you're all quite familiar with this already. So you must know what is ground state, excited state, and energy level. So this is the formula to calculate the energy level. Sorry, okay, that's a bit not aligned. The formula I think you should know. Okay, after that you must know how to calculate E is 3, E4, and then okay, okay, here is the formula. You should know, right? Okay, all the formula. This is energy of an electron in certain state. Okay, must remember the E. This is En. Depends on the question. 1, 2, 3, 4 until infinity. So negative RH. There is a negative RH. 1 over N2 squared. So RH is Rabbit constant 2.18 times 10 to the power of negative 18 joule. Okay, another one is the energy change, delta E. So here the special one is 1 over n initial square minus 1 over n final square. Again, the Rabbit constant is the same. Next is frequency, mu equal to c over lambda. C is a speed constant, 3 times 10 to the power of 8 meter per second. Okay, lambda make sure is in meter. Okay, next is about another formula for delta E H mu. Just now we know, right? Okay, mu equal to c over lambda. If substitute, you will get h c over lambda. And then this is wavelength. Wavelength, okay. This one we call 1 over lambda we call as wave number equal to RH 1 over n1 square minus 1 over n2 square. So always remember n1 is smaller than n2. Okay, have to check. Sometimes given in nanometer, you must convert into meter. Okay, before start the calculation. Okay, always remember n2 is larger than n1 or n1 is smaller than n2 because lambda must be positive value. So these are the formula you should know. Okay. Okay, after all the formula, right? Okay, you also have to know what is spectrum. So there are two line spectrum and continuous spectrum. You must know the difference between them and then give the example. Okay, so this one, right, is the electromagnetic wave diagram. Okay, you have to check. The part we are going to discuss is ultraviolet region in Lyman series, visible Bauman series. Okay, bracket, PFAM, Paschen, infrared. Okay. So only visible region, right, we can see the color. So the formation of the continuous spectrum, line spectrum, you should know. Okay. And then this is energy level diagram. Okay, when the electron, right, when the energy absorbed by the atom, okay, will cause the electron move. Okay, always remember it's electron, okay, move to higher energy level. But at higher energy level, the electron is not stable, so it will fall back to a lower energy level. When you fall back to a lower energy level, right, you will form the line spectrum. Okay, I want to ask, right, still remember how to identify the line spectrum with the line produced from the energy level diagram based on the, you can base on the distance. Okay, you check here. Okay, the distance here, the distance. So who won't that this is the first line of the Lyman series. Check the distance. Okay, I can draw like this as well. Okay, so here is the first line. Here is the first line. Okay, how to form the line? From n equal to 2 to n equal to 1. This is for your understanding, but you don't need to write it. Okay, and then you check for the energy, right? Among these A, B, C, D, okay, this one has the highest energy, highest delta E, meaning that this one has the highest delta E, and then automatically the frequency is the highest, but has the shortest wavelength. Okay, always remember, you have to know how to identify the largest energy, okay, the highest frequency, and then the shortest wavelength. Okay, always remember, you check, because this is from 5 to n equal to 5 to n equal to 1 should have highest delta E. Okay, and then delta E is directly proportional to frequency, and delta E is inversely proportional to lambda. Okay, next. Okay, this is what I said just now, the region, spectrum region. If you check the past year, right, the question keep on asking, oh, this line belongs to which region, located at which region, you should know. So Lyman, ultraviolet, Balmer, visible, Hutchin, bracket, prefarm, infrared. To identify the shortest, longest, okay? This is the formula for 1 over lambda. Okay, many of you, right, keep on asking, madam, Rabbit constant. Okay, Rabbit constant must always remember if 1 over lambda for the wave number or to calculate the wavelength, right, is 1.097 times 10 to the power of 7 per meter. And then for delta E, the Rabbit constant is 2.18 times 10 to the power of negative 18 joule. So be careful. You have to check which formula you want to apply. After that is about IE. You must know the definition of IE. And then, okay, if IE, right, meaning that the electron is at n equal to infinity. So 1 over n 1 over n f n square final is 1 over infinity. And then some of the students ask me, 1 over infinity, macam mana nak tekan calculator? Actually, it's equal to 0. Okay, so the answer is still the same, 2.18 times 10 to the power of negative 18 joule for removal of 1 electron. If the question asks about for removal of 1 more electron, you have to times the number of Avogadro. Okay, if 1 more electron. So the question might ask ask like this, okay, by using energy level or by using wave number or lambda as well. Later we check past year, there is one question is related with wave number, and then you will get the same answer. First step you will get 2.18, second step you will get this one. Okay, simple question. So this is when n equal to infinity or the lambda infinity, right? Okay, here we will have the convergent line. Okay, as the frequency is the highest from here, and then the lambda is high increase. Okay, inversely proportional. Okay, last is about the weakness of both atomic model, and then you must know about de Broglie postulate and example uncertainty principle. So this is 2.1. Any question about 2.1?
No.
No, clear. Okay. 2.2 is about orbital, quantum number, and the shape. So orbital, you have to know the definition. And then quantum number, there are 4 NLMS. You must know all the function of each principal quantum number. Okay. First, I just have a quick review with you all. Actually, you should know already. Okay. Because I share the video with you all. Got GM from other class, got my personal YouTube video. Okay. Don't tell me, Madam tak ajar, Madam tak cakap, Madam terlalu cepat. Because right, all the video you can keep on rewind for infinity time. Okay? If you got question, you just ask. Okay, I am doing the revision with you all now. If you got question, you just ask. Okay? So you have to know the N determine the energy. At the same time, it determines the size of the orbital as well. You can add one note because you check right. Okay, if N equal to 1, the size like this. 2 bigger. Okay, 3 getting bigger. So beside the energy, actually when N increase, the size of the orbital increase as well. Okay, N is started from N equal to 0 until infinity. Okay, you can check. Okay, the size getting increased. Okay, this one is 3s bigger. Second quantum number is L value, which is azimuthal subsidiary quantum number, or we call it orbital quantum number as well. Okay, it from 0 to n minus 1. Okay, and so we must know the n value that only can determine the L value. Okay, function, shape, and type. So you must remember when L equal to 0, we know the subshell is S orbital. When L equal to 1, P orbital. L equal to 2, D orbital. L equal to 3F. L equal to 4G. Don't tell me, Madam, why? Actually, no why. This is a fact. Okay, this is a fact. When L equal to 0 is S orbital. So the S orbital with spherical shape. Okay, when L equal to 1, okay, is P orbital with dumbbell. L equal to 2 is clover leaf. Okay, so we have to know how to draw the SPD orbital as well. Okay, next, magnetic quantum number is from negative L through 0 to positive half. Okay, and then L determine Y. So for example, when L equal to 0, M0. L equal to 1 is from negative 0, positive 1. Okay, negative 1, 0, positive 1. The negative and positive side insists for magnetic quantum number. Okay, and D, so it's from negative 2 until positive 2. Based on here, right? Okay, that's why we know what L equal to 0 S orbital, only one, for S subshell, only one orbital. I repeat again, when L equal to 0 is S subshell. So S subshell only have one orbital. One orbital can accommodate or can place 2 electrons. So that's why one possible orbital S subshell, okay, can put 2 electrons. Okay. And then L equal to 2, there are 3 possible orbitals. Okay, that's why if you check, right, there are Px, Py, Pz. Okay, 3 possible value, 3 orientation, so P subshell. Okay, for D orbital, dxy, dxz, xz, dyz, dz square, dx square, minus y square. So that's why there are 5 possible orbitals. So each orbital can place 2 electrons. That's why maximum electron for D orbital is 10, for P orbital is 6, for S orbital is 2. Get the idea?
Yes.
Azina. Azina?
Yes, madam.
Azina? Okay. When n equal to 5, what are the possible value for L?
0, 1, 2, 3, 4.
Okay, very good. Okay. Try to call one of your friends' name, random. Azina panggil je. Nama siapa-siapa. You nampak siapa, you boleh panggil je. Tolong Madam panggil salah seorang.
Atika.
Okay, Syafika.
Atika.
Atika.
Yeah, madam.
Okay. When n equal to 5, L equal to 0, what is the subshell?
5S.
Very good. Okay. How about this one? When n equal to 5, L equal to 3.
5F.
Spdf. Very good. 5F. Okay, call one of your friends' name.
Farah.
Farah. Farah, when L equal to 3, what is the possible value for M?
-3, -2, -1, 0, +1, +2, +3.
Very good. Okay, +1, +2, +1, +2, +3. Very good. Okay, Farah, I would like to ask you, total there are how many orbitals in this case? When L equal to 3, M equal to -3 and +3, so there are how many orbitals? Hi, Farah. Based on who?
7,
Yeah.
7.
Sorry?
7.
What's your answer? Yeah, very good. 7. Yes, 7 possible orbital. Okay, try to call another name. Try to call guys. Farah, panggil nama je. Panggil lelaki.
Sorry, medium line. I teruk. I tak dengar sangat.
Oh, teruk. Okay. Siapa? Okay, lelaki. Kita tengok lelaki siapa. Harry. Harry Young.
Yes,
Harry Young.
madam.
Okay, if there are 7 orbital, right? So, how many electrons can place for these 7 orbitals? Maximum electron.
Seven ke, madam?
Ya, Harry, sila jawab soalan dia. Tadi Farah dah beritahu, okay, when L equal to 3, M equal to, M equal to this value from -3 until +3, there are 7 orbitals. So my question is, for this case, maximum electron for 7 orbitals is
7.
7, right? Electrons can place for how many electrons for 7 orbitals? Just now we discussed, okay, for S subshell, 1 orbital can place 2 electrons. 1 orbital can place 2 electrons. 3 orbitals, so can put 6 electrons. 5 orbitals can put 10 electrons. If there are 7 orbitals, can put how many electrons?
14.
Okay, 14, don't stop first, 14 electrons. So now my question, when n equal to 5, okay, can put how many electrons?
Macam mana tadi, madam?
Kalau, okay, ini ialah, okay, semasa L sama dengan 3, okay, N sama dengan 5, okay, I pilih spesifik, L sama dengan 3. When L sama dengan 3, okay, ada 7 orbital, boleh letak 14 elektron. Sekarang soalan saya tukar lagi, I tukar, semasa N sama dengan 5, maksimum elektron berapa? You can use this formula. Okay, okay, 2, N equal to berapa tadi saya tanya? N equal to 5, right?
5.
Yeah, so berapa elektron?
50.
Yes, 50. Tahu 50 tu datang dari mana?
Datang daripada 5.
Okay, beritahu saya. Okay, kita tengok satu demi satu macam mana dapat 50 ya. So tadi ini tahu 7 kan? Ini 7 orbital. So ini ada S ada 1 orbital. P ada berapa orbital? Harris, kalau P ada berapa orbital? When M equal to 5, L equal to 0 is S orbital. Is S subshell. So 1 orbital. But L equal to
3, madam.
when L equal to 2. Haris, madam dah bagi clue.
5, madam. Sorry, madam. Saya sangkut tadi.
Oh, okay, sangkut.
Saya ingatkan madam sangkut.
Okay, yang ini, when L equal to 4, dia akan jadi 9. Tahu mengapa 9? Negative
Oh.
4, negative 3. Jadi jumlah you kira berapa orbital kat sini? Tambah, 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 tambah. Equal to 25.
20.
Okay. 25 times 2 because one orbital can place 2 electrons. That's why the answer is 50. Ini sebab dia. So we can try to apply this formula to calculate the maximum electron in main shell. Main shell sahaja. Main shell means n equal to 5. So we must know the basic concept of NLMS to help us answer various type of tricky question. Okay, the question may be specific. They ask you phi P, phi S, phi D, or n equal to 5. Okay, positive half or negative half. Okay, some sort like this. Okay, so let's continue. Very good, meaning that you got the understanding. Okay, about NLMS, and then always remember n limit L limit M. Okay, so this is S. S there are two value, just two value, positive or negative half. Positive half is clockwise, negative half is anti-clockwise. Okay, so there are various questions about NLMS. You must know how to answer. And then what allowed, not allowed. Okay, this is the fill in the blank. Okay, 3, when n equal to 3, L equal to 2, what is the subshell, possible m value, orbitals, okay, and so on. Okay, I hope you're all right. Try all the exercise in lecture notes. Okay, and then you can check through my video. My video did explain all the exercise. Okay, next we proceed. Okay, after the NLMS is about drawing. Okay, you must know how to draw the s orbital. Okay, want to ask you all, is it correct, the diagram of this picture?
No.
No, incorrect. Start salah. You have to draw the axis properly. Okay, you have to show all the axis x, y, z. Okay, and then the middle one you just erupt this or erase it. Okay, you can, if you watch my video, you know how to draw it properly. Okay, this is the two. This is the P orbital. P orbital, no problem. PZ on the loops of Z. PX on the loops of PX atas paksi lah. And then PY. Okay, PY. Okay, problem here. Many of you can't draw the DXY, DXZ, DYZ, DZ square. So please check my video. I did guide you all how to draw it. Okay, so after 2.2 is 2.3. 2.3 is about alpha principle, Hans-rule, Pauling exclusion principle. So you must know these three rules in order to help you to fill in the electron or write down the electronic configuration. Okay, when you write down the draw the atomic orbital or Spdf notation, right, there are some rules you must follow, and then explain the anomalous cases for copper and chromium. So based on here, right, this one is okay, I use this one. Okay, this one we call orbital diagram. Okay, stick to one method using platform. Okay, this one is Spdf notation. Okay, how to write down the Spdf notation or orbital diagram based on the proton number. Okay, based on the proton number. So how to check the proton number based on the least constant. So when you know, right, okay, there are 8 electrons. Oh, sorry, the proton number of oxygen is 8, so there are 8 electrons for oxygen. So you follow 1s2, 2s2, 2p, 4. How to draw this? Okay, we have to start from alpha principle. I have to draw the staircase like this, so that I know, okay, I have to fill in 1s first, followed by 2s, then 2p, 3s, and so on. Because according to alpha, electron fill the lowest energy orbital first and other orbital in order of ascending energy. Okay, so this is the order of filling electron. Please be careful for this part. You have to fill in the 4s first, then only 3d. Because 4s has lower energy compared to 3D. But after we fill in the electron, right, okay, we have to follow the n value. Okay, for example, okay, later we check. Later I will show you the example. Okay, so simple. After that is about Pauli. Pauli say, right, impossible. There are two electrons with the same atom have the same 4 quantum number. So meaning that each electron must have different set of quantum number. So for example, in this case, 1s, okay, n equal to 1, l equal to 0, m equal to 0. But s show one is positive half, another one is negative half. That's why impossible there are same set of quantum number. Tak mungkin akan sama. Walau n, l, m sama, last kali s mesti berbeza kerana satu ikut clockwise, satu anti-clockwise. Okay. Hans rule kata apa? Hans rule normally happen for the 2p orbital. Because the definition of Hans rules, right? Set of degenerate orbital. Degenerate orbital means sama. Contohnya yang sama ialah 2p. Mereka sama energy level je. Px, Py, Pz sama je. Okay, jadi kita buat apa? Each orbital must fill singly with electron of the parallel spin. Satu, satu, satu dulu. Share equally first. And then with the same spinner before the electron occupy the orbital in pair. So ini yang Hans rule kata. Okay, so these are the 3 main rules you need to know. Okay, then after that, you try to fill in the electron and then apply the alpha, Hans, and Pauli exclusion principle. Okay, and then there are 2 exceptional cases happen for chromium and copper because, right, okay, if according to alpha 4s2 3d, then 3d4 for chromium, but actual one is 4s1 3d5. One of the electron from the 4s orbital transfer to 3d. Why? Because the 3d5 half-fill orbital or half-fill subshell, right, have the extra stability. Same for copper. One electron from the 4s orbital will transfer to the 3d orbital so that it make it become 3d10. Yeah, because if according to alpha, so is 4s2 3d9, but actual way is 4s1 3d10 due to the completely filled 3d subshell have extra stability. Okay, so this is 2.3. So now, okay, this is the tutorial for 2.1. I think all of you have completed already. Very good and submitted. Okay, only Nick ada ke tak? Nick, dah hantar ke belum? Nick. Okay, this is 2.2. Okay, if you check my video, right, I did discuss with you all. Okay, 2.2. Okay, and then 2.3 about the definition. Okay, and then 2.3 guide you how to write down the Spdf notation. So this one is Spdf notation. Spdf notation. Tak ada comma, dia straight je. 1s2, 2s2, 2p6, 3s1. Yang s2, p6, s1 tu kat atas subscript subscript, superscript. Okay, and then orbital diagram is like this. Okay, half arrow only. Okay, now we start our lesson after half hour of briefing. So we continue our lesson by discuss tutorial 2.1. Are you ready? Yeah. So because there are 2 classes, right? Okay, I will random pick. Okay, who's supposed to answer this one? Okay, so question number 1. Fidas. Okay, try to explain to your friends about the question, and then start to answer. Explain your answer. Okay, Fidas, your turn first.
Okay, hello. For the first question, figure 2 shows the Balmer series of hydrogen emission spectrum. So, number 1, A1, state the electron transition that produced line B.
Okay, before we proceed, right, any clue from the question?
The clue from the question is Balmer series.
Okay, so Balmer series, you should know what it is.
2.
Yes, you should know n equal to 2. Very good. Okay, then continue.
So my answer for 1A1 is the electron transition that produces line B is transition of electron is from n equals to 3 to n equals to 2.
N equal to 3 to n equal to 2. Okay, let's check, is it correct? Line B, right? Question asked about line B. This one, right?
Hmm.
Okay, so I would like to ask you, right? A, B, C, D, E, which one is the first line of the series?
A.
A. How to produce line A? Based on your answer, right? Okay, you tell your answer is from n equal to 3 to n equal to 2, right? So question asked about line B. So do you think your answer is correct?
I think.
You know why we check for another class, the answer from another class? Yeah, we discuss. No worry, no worry. We just discuss. Okay, we check for this class. Who is the question one? Question one. Why not question one? Electron. Class ini siapa yang buat soalan satu? M7?
Me, madam.
So what is your answer? I didn't see.
I put higher energy level to a lower energy level.
Okay. Too general. For sure, this is not the answer. Okay. Okay, so this is the first question, but seems like you can't get what the question asked about. Okay. Okay, everybody, please check this question. Okay, Firdaus tadi cakap line yang mana line pertama?
A.
This is the first line. Why?
Because the wavelength.
Okay, the wavelength. Okay, the distance between the two lines is the greater.
Yes.
Okay, so this is the first line. Okay, if we check, right, based on the energy level, okay, so this is n equal to 2 because Palmer series, right?
Yes.
So the first, n equal to 2. So which one is the first line to form the first line to form the Palmer series? This is n equal to 2. So this one n equal to 3. So this one n equal to 4. So which one is the first line? 3 to 2, right?
Yes.
Then 4 to 2. Then
5 to 2.
5 to 2. Okay. So from here, you know which one is the first line? A, right? So this one is A. So this one is
B.
B. So do you think your answer correct? The question asks about line B. State the electron transition that produce line B. So what is the correct answer?
For n equals to 4 to n equals to 2.
Yes. Okay, get it? Be careful. So the transition of the electron is from n equal to 4. Okay, class? It's from n equal to 4. Okay, is n equal to 4 to n equal to 2. Okay. You have to be specific. Okay, for the Alvin, right?
Yes, madam.
Be careful. So you give the wrong answer. Okay. Okay. Question number 2. Okay, Alvin, you answer. Question number 2. What? Thank you, Firdaus. Alvin,
Okay.
explain the formation of line B. How to explain? What is the key point to explain this question?
Need to explain how it from a higher energy level to a lower energy level.
So please tell me the key point based on your question. Okay, I try to zoom it. You write your answer. You tell me the keywords for this question.
Formation of line B.
Yeah, I know there are panjang lebar there, right? You tell me which one is the first point, second point. Okay, you try to tell your friends, or present to your friends.
So the first point is electron in hydrogen. possesses a quantized of energy.
Okay, so the main point is quantize energy. Okay, then
And it occupies the ground state.
okay, ground state.
When the electron of the hydrogen atom at its ground state absorbs sufficient amount of energy, it will be promoted to a higher energy level, or known as excited state.
Okay, very good. So so energy promote to a higher energy level, and then we call it as excited state. Okay, good. Next.
Electrons are usually unstable, unstable at excited state and uh, tend to fall to a lower energy level.
Okay, yes. Okay, usually unstable, so it will fall back to a lower energy level. So in this case, is the n equal to 2. Oh, very good. Okay, Alvin answer specific because based on this case is Balmer. Okay, next continue.
And during the transition of electrons from a higher energy level to a lower energy level, the radiant energy is emitted in the form of light or photon.
Okay,
The,
yes.
the photon or light has special frequency or wavelength which produces the line spectrum in the visible region.
Okay, very good answer. Okay, so Alvin answer correctly for question number 1B. So this is the answer. Okay, and then A3 continue.
It's the other.
Okay, question now I show you the question first. Okay. Calculate.
The energy photon that produces line C with wavelength of 434 nm.
So what should you do first?
First need to convert.
Okay, must convert the wavelength into meter. Okay, so let's check the formula you apply. So you are using 1 over lambda. Yes, correct. Okay, you know the energy. How do you get this answer? You didn't substitute correctly.
Because madam, they give wavelength.
Okay, they give wavelength. The question asks about delta E, right? So do you think you're using the correct way to calculate delta E? The question asks about delta E, right? Let's check. Is it delta E? Energy. Yeah, the question asks about energy. So which formula you are going to use? I didn't see any delta E based on your formula. The question asks about delta E. So how to find the delta E? 1 over lambda or lambda, yes, I know. Energy level, I know already what, because line C. Line C, I know. Line C is from, okay, this one, 2. Line C, this one is 2, right? Okay, Balmer series, first line, so 3 to 2, 4 to 2, 5 to 2. So I know the energy level already. So from n equal to 5 to n equal to 2. So what for? You choose this formula. Okay, never mind, we check Fidal's answer. Okay, yes, Fidal using, okay, Fidal, you pakai formula apa? You using HC over lambda, right?
Yes, madam.
Okay, 4.58, yes, correct. Okay, delta E, you get 4.58 times 10 to the power of negative 19 joule. Yes, this is the answer. Okay, very good. Actually, right, you all can using this formula as well. Delta E equal to RH 1 over n initial square minus 1 over n final square as well. Both will get the same answer. But for this, right, you will get the delta E equal to negative value. Correct, no problem. Just make a conclusion. Energy release is 4.58 times 10 to the power of negative 19 joule. Okay, yeah? So good. So this is the answer for question 1. Okay, thank you, Elwin, Elwish, and Fidaus. Okay, next. Question number 2. Whose turn? Okay, question number 2. Let me check next. Question number 2, Harry. And this one, question number 2, Harris. Okay, Harry dan Harris. Okay, Harris dulu.
First, is asked to describe the formation of the line emission spectrum of hydrogen atom in the Lyman series.
Okay, formation. Okay, and then number 2.
Calculate the ionization energy in kilojoule per mole of the hydrogen atom using figure 1.
Okay, then
Name 2 species that exhibit similar line spectrum as that of hydrogen atom.
2 species are similar with the hydrogen atom. Okay, before we try to answer the question, describe, calculate, name, right? Okay, we check. This one is under which series? This question is under.
Lyman series.
So what should you know about Lyman series? What should you know about Lyman series? N equal to?
N equals to 1.
Okay, N equal to 1. Okay, this is wave number. Given is wave number, check what is the unit given.
Micrometer.
So if I want to change to meter is?
1 over.
1 over can or times 10 to the power of?
8.
Huh? Are you sure it's 8? Micro. Plus what is micro?
6.
10 to the power -6.
Yes, -6. Okay kena alert Okay, so kita tengok describe formation of Harry. Tengok jawapan dia macam mana. So do you notice, right? Actually the answer, right, to describe how to form the line spectrum actually is the same. Okay, the concept is the same, but you have to be specific. Because just now the question number 1 is Balmer series. So you have to talk about Balmer series. So the electron will drop to n equal to 2, which is the lowest energy for this case. In this case, you have to drop to n equal to 1, Lyman series. Okay, so never mind, we just recomment how to form the line emission spectrum of hydrogen in Lyman series. Okay, Harris, what's your keywords? Okay, let's check. Okay, I enlarge it. Okay, so Harris, what is the keywords? So first one?
The electron in the hydrogen atom possesses a contrast energy and it could pass the ground state.
Okay, good. Then?
When the electron of hydrogen atom at its ground state absorbs sufficient amount of energy, it will convert to a higher energy level or excited state. Electron is unstable at excited state and falls back to the lower energy level, which is n equals to 1.
Yes, very good. You have to add which is n equal to 1. Jadi kena tambah which is n equal to 1. Then continue.
During the transition of electron from a higher energy level to a lower energy level, the radiant energy with specific frequency is emitted in the form of light.
Okay, form of light kena bracket beritahu ialah apa?
Photon.
Yes, photon. Specific frequency, specific wavelength. Okay, yes, very good. This is the answer. Right? Is it same as just now, right? Same as question 1. It's the same. Okay, just the lower energy level different. Just now is n equal to 2, this one is n equal to 1. Very good. Thank you, Harris. Now, Harry. Okay, Harry, your turn. Harry, question number, calculate, okay? Calculate the ionization energy. Cuba terangkan mengapa buat macam ni.
Okay. First, guna formula sekejap, saya lupa.
Formula dah betul, dah sambung je. Dan pelik, adakah semasa you guna formula akan dapat nilai ni?
Dia dapat nilai, dia memang dapat nilai itu lah, madam.
You cuba tekan kalkulator sekarang, tengok dapat nilai ni ke?
Kalau tak, macam mana saya boleh dapat jawapan tu dia, madam?
You tekan kalkulator, kalau boleh you share screen, tekan kalkulator bagi saya tengok macam mana you dapat ni.
Okay.
Saya tengok Harris punya jawapan. Yang ini baru betul. Okay.
Oh.
You dapat nilai apa?
Kerana saya kira saya pun tak tahu benda. Tapi saya dapat jawapan macam tu.
Pandainya step you. Terus dapat jawapan. By right, you should get, okay. Formula betul, kira macam betul. Tapi kuasa salah juga, Harris. Kuasa you salah juga. So, Harry, you dapat apa jawapan sekarang? Harry dapat apa jawapan? Sila bacakan.
Saya 2.18 10 kuasa negatif 18.
Yes.
Lepas saya tertinggal satu jalan kerja, madam.
Yeah. Okay. So you should, first of all, right, you should get the answer 2.18 times 10 to the power of negative 18 joule first. Okay. This is, okay, the energy removed by one electron. Okay, you have to continue. You have to continue to calculate the IE times by using 2.18 times 10 to the power of negative 18 joule times the number of Avogadro. Okay, please take the number of Avogadro 6 point something, then only you get this answer. Okay, so the unit is kilojoule per mole. Tengok you tahu tulis joule per mole, tapi kat last kali you tulis kilojoule je. Nilai betul, unit salah, salah. Boleh faham?
Faham, madam.
Okay, so bagi Harry pula tentang mengapa kuasa salah dan lupa tulis unit. Okay, tapi jawapan akhir 1.32, okay, times 10 to the power of negative 3 pun salah dah kerana sini kuasa salah, sini salah. Okay, now we proceed with C. Sodium mercury memang tak boleh, salah. Yang ini tulis apa? Helium lithium pun salah. Okay, soalan tadi apa? Mengapa dua-dua belajar salah? Okay, let's check. Name two species that inhibit line spectrum, hydrogen atom. Hydrogen atom berapa elektron? Harry ataupun Harris? So how many electron for hydrogen atom? Satu, yes. 1 electron. So jawapan anda you bagi helium. Helium ada berapa elektron? Kat periodic table kan, hydrogen kat sini, lepas tu helium, and then lepas tu lithium, okay, lepas tu beryllium, boron, okay, they're arranged according to proton number. So this one proton number 1, this one proton number 2. So there are how many electron for helium? Two. Okay, very good, 2. Okay, jadi kalau berdasarkan Bohr's atomic model, dia hanya boleh explain spesies yang hanya ada satu elektron. Sekarang helium ada 2 elektron. Kalau I nak jadi dia 1 elektron, kena buat apa?
Share.
Share? I nak 1 je. Sekarang ada 2, ada 1. Sekarang I nak 1 je. Buang lah.
Tapi instead of buang, kita boleh share, madam.
Bukan. Sekarang I nak jadi helium dia 1 elektron je. So maksudnya I kena jadi dia He positif. I buang 1, dia akan jadi positif. Betul tak?
Betul, madam.
So that's why the answer suppose is helium positive, not helium. Helium is wrong. Lithium is wrong as well. Lithium, because there are 3 electrons for lithium, if I want to remain only 1 electron, meaning that I have to remove 2 electrons. Once I remove 2 electrons, it's become lithium 2+. So these are the answer. Of course, you can use as another example, for example, beryllium, boron, but you have to remove more electrons. So we try to take the simple one, helium positive, lithium 2 positive. Get it, class? Okay, so we have to name the 2 species that inhibit similar line spectrum as the hydrogen atom. Hydrogen atom, only 1 electron. So we have to find the species with only 1 electron. So the answer is helium positive or lithium 2 positive. Okay, thank you, Harry and Harris. Now we proceed with question number 3. Okay, question number 3. Again, line spectrum. So we must know how to read the line spectrum. Okay, let's check. Question 3 for this class. Question 3. Okay, Shami and Lokman. Okay, Lokman first. Lokman?
Yes, madam.
Okay, jom kita study question dulu. Question cakap apa?
Dia nak region of electromagnetic spectrum.
Oh, region. Apa kemungkinan untuk jawapan dia?
Dia ada ultraviolet, visible dengan infrared.
Betul. Okay, jadi yang ini kita soalan tanya apa?
Cakap in the bracket series.
Yes, bracket series. So bracket series, apa electromagnetic region dia?
Infrared.
Infrared. Yes, good. Okay, you get the first mark. Okay, and then Madam nak tanyakan Luqman macam mana nak baca benda ni? Bracket N equal to berapa?
Equal to 4.
4. Okay. So which one is the first line? A, B, C, D?
D.
D. Mengapa?
Sebab wavelength dia tinggi, panjang.
Okay, jarak antara dua line tu lah kita tengok jarak terus ha. Okay, so macam mana nak bentuk line D? Line D ni terbentuk dari macam mana? Dari N berapa drop ke N berapa akan terbentuk line D?
N equal to 5 to N equal to 4.
Okay, yes. Okay, how about line A?
N equal to 8.
To N equal to
4.
Okay, so betul. So sekarang, okay rasa cukup bagi Luqman. Okay, kita sambung lagi siapa dia seterusnya. Terima kasih Luqman. Okay, kami.
Ya.
Okay, sambung ha. Kita tengok ha. Soalan sekarang tanya apa?
Wavelength.
Wavelength. Panjang ke pendek?
Pendek.
Okay. Jawapan dua je, antara dua je. Sama ada A ataupun D. Jadi A ke D?
A.
A. Okay, A shortest wavelength. Mengapa?
Sebab dia paling pendek.
Dia paling pendek. Yes, dia paling pendek. Because right, if we check the sequence, right? Okay. Okay. From line D until line A, okay, what happened? Delta E increase, right? Frequency increase. So lambda decrease. So okay, that's why A has the shortest wavelength. Okay, calculate the wavelength that produce the line. So line A tadi Luqman dah kata 8,4. So kita tengok jawapan Syami macam mana. So let's check the answer. Betul tak? 7,3.
Saya letak 7.
So sekarang bracket N sama dengan berapa? Okay, Syami, berilah saya N sama dengan 1, apa nama dia?
Lemon.
2,
Balmer.
3,
Passion.
4,
Bracket.
5.
P-Fun.
Okay, so kena tahu that's why you jawab silap dah untuk bahagian ni. Kerana identify the wrong energy level. Okay, tak apa, kita tengok Fidaus sebenarnya, tengok cuba. Fidaus betul tak? Bukan Fidaus pula. Okay, Syami cuba tengok jawapan Luqman. Betul tak jawapan dia?
Betul.
Betul. Okay, first dia tulis formula. Ada something silap. Beritahu saya dia silap kat mana? Silap sedikit. Luqman tahu silap kat mana? Ada silap sikit. Or anyone?
N1 less than N2.
Yes. Wajib tulis. Okay ya. Dan boleh substitute. Semua ni, semua betul tak? Unit pun betul. Soalan tak suruh tukar nanometer tak payah. Okay. Kalau soalan suruh baru tukar. Okay, tak suruh. Yes, you remain the answer 1.94 1.945, 1.946 times 10 to the power of negative 6 meter. Okay, siapa yang sudah tukar pun tak salah. 1944.7 nanometer. Okay, good. Thank you, Lukman and Shami. Shami, be careful. Okay. Okay, now we proceed question number 4. Question number 4, Izzat and Aiman. Okay, Izzat dulu.
Hello.
Izzat, soalan pertama ialah apa?
Describe the formation of emission spectrum for hydrogen atom and show and label the first 3 series of electron transition between energy levels.
So describe. Adakah sama dengan depan? Sama dengan soalan 1 dan 2 kan? Okay, jom kita tengok jawapannya sama tak? Okay. Okay, semua nampak tak? Okay, cuba tengok So, keywords.
The electron in the hydrogen atom possesses a quantized energy and occupies ground state. And then when the electron of a hydrogen atom at its ground state absorbs sufficient amount of energy, it will be promoted to a highest energy level.
Kat sini apa yang kurang?
N equal to.
Bukan, you kena cakap apa? Higher energy level kita panggil apa?
Excited.
Okay, is called as excited state. Tadi kawan semua pun tulis Okay, lepas tu sambung.
Electron is unstable at the excited state and fall back to the lower energy level.
Okay, kat sini ada point yang kurang. Beritahu saya kurang apa?
During the transition.
No. Tadi kawan ada dua dan mereka semua jawab dengan bagus. Mereka ada mention. Kita tengok balik jawapan mereka. Ni. Kita tengok. Ni bagus nampak jawapan. Okay, tengok tadi. Kita tengok betul. Jawapan Harris ada tulis dengan jelas. Okay, tengok promoted higher energy level, dia ada berita excited state. Okay, excited state fall back. So, lepas tu, dia ada berita apa? Radiant energy or release energy with specific frequency in the form of light. Kena beritahu photon. Ini penting. Dia tak beritahu Harris. Elwin pun beritahu. Elwin, tengok jawapan Elwin lengkap sekali. Okay. So, nampak tak? Specific frequency or wavelength which produce light spectrum in upper region. And then have to mention about yang penting ialah the radiant energy is emitted in the form of light or photon. Ni kena beritahu. Faham? Okay be careful Okay, kalau dia tengok jawapan Aiman. Okay. Fidaus tadi jap. Okay. Izzat, cuba tengok jawapan Aiman, you beritahu saya. Nampak tak? Jawapan dia betul ke salah? Oh, yang ada dia ada ke tak?
Ada.
Tengok betul-betul, jangan jawab ada je. Beritahu saya. Okay, point 1 dia ada ke tak? Apa yang kurang kat point 1?
The electron is hydrogen process of quantized.
Dia ada tapi dia kat bawah. Dia ada tulis tapi dia kat bawah. Dia tak tulis excited state juga. Okay. Lepas tu unstable and then fall to a lower energy, release corresponding to certain wavelength. Dia sama dengan anda juga. Dia tak tulis photon juga. Okay. Please take note Aiman dan Izzat kena be careful Okay. I know some of you refer the reference book. Dia tak tulis macam sedikit macam tu. Tapi mana nak standardize you all, kita cuba buat yang terbaik, jawab yang paling lengkap sekali. Okay, lebih bagi, jangan bagi kurang. Okay, ya. So try to answer because you check, right, the question is the same. Actually, it's the same. Describe the formation, describe the formation. So after this, the question related with describe the formation of line spectrum, memang akan skip dah. Kadang sudah discuss 3 kali ya. So I hope every one of you get the idea how to answer the question related with how to form the line spectrum, how to form the emission spectrum from a hydrogen atom. Okay or not, class?
Okay, madam.
Okay, ya. I discussed 3 times already ya. Okay, very good. Next. Okay, Aiman, soalan seterusnya nampak tak? Okay, jawapan betul, sangat lega. Thank you, Izzat. Okay, Aiman?
Yes, madam.
Bagus lah jawapan ni. Mengapa you buat 1, 2, 3, 4, 5? Kerana soalan tanya apa?
Soalan yang minta show and label the first 3 series of electron transition between energy levels.
Okay, ni nak first 3 series. Okay, so 3 series termasuk apa?
Lyman, Balmer,
Hutchin. Okay, dia tunjuk 5 lah. Ini 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4. Oh, okay, sebenarnya boleh bagi sama. 3 cukup. Tunjuk 3 Lyman, 3 Balmer, 3 Hutchin. Okay dah. Bagus ah. Okay, lepas tu kiraan macam mana? Kiraan dia tanya apa pula?
Okay, untuk kiraan dia tanya an electron is a hydrogen atom is transferred from n equal to 5 to n equal to 3. Calculate the energy of the photon emitted and the wavelength of the spectral line produced.
Okay, dia suruh kira energy, maksudnya delta
E.
Okay, wavelength sama dengan lambda. Okay, kelas berhati-hati ya. Soalan dia ada 2. Pelajar dia sangat excited. Calculate the energy. Dia terus kira energy. Dia lupa baca ayat yang seterusnya. So please take note N. Wavelength. Ya. So kira energy betul tak? Okay, energy dia pakai formula ni. 5-3. So kira. Okay, very good. Dia memang jawab macam skema. Okay, formula, substitution, final answer with the negative side and then make the conclusion. Okay, energy of photon emitted, energy released. Okay, ini wajib ah. So next, kira mu dulu, kemudian guna lambda. Okay, dapat jawapan 1.28 times 10 to the power of negative meter. Okay, ataupun boleh guna formula lain. Kita tengok Izzat punya, ada tak dia guna formula lain? Oh tak, dia guna formula yang sama juga. Okay, sebenarnya kita boleh guna formula untuk kira ni kan, kita boleh guna formula 1 over lambda juga. Okay, kita boleh guna 1 over lambda pun akan dapat jawapan yang sama juga untuk kira lambda. Okay, very good. Okay, thank you Aiman. Thank you Izzat. Okay, so now we proceed for the next question.
Okay, madam.
Question 5. Anwar, you bagi apa jawapan? Madam tak nampak dengan jelas.
Sorry madam. Nak saya send balik lah?
Tak apa, you terangkan soalan dululah. Okay, Anwar terangkan soalan. Kita tengok jawapan Satya. Okay, Aiman, terangkan soalan 5 nak kira apa?
Okay, in the hydrogen atom, an electron transition from a higher to a lower energy level emits a photon with a wavelength of 1282 nanometer in Passion series.
Okay, based on here, what can you analyze about this information?
We got the wavelength.
Wavelength kena buat apa?
Times 10 power of negative 9.
Okay, and then this one, n equal to? Passion series n equal to berapa? Tadi baru I tanya je kat sini.
3.
3. Okay, so soalan nak tanya apa?
Determine the energy level of the excited state for this transition.
So maksudnya dia nak tentukan n. Okay, n2 or n final. No, n initial. Okay, sama ada nak tentukan n2 ataupun n initial. Depends which formula you are using. Okay, lagi state the
radiation region for this transition.
Okay, beritahu saya radiation region untuk partial series kat mana?
Infrared.
Okay, infrared. Okay, terima kasih. Betul. Okay, jom
Sama-sama.
kita tengok jawapan 5A1A. Okay, jawapan Anwar tak dapat tengok. Okay, kita tengok jawapan Satya. Okay, very good. Tapi juga ada silapan. Siapa boleh beritahu ada silap kat mana? Kelas. Please.
N1 less than N2.
Yes, please. Okay. Okay. Satya.
Yeah, Marian.
Okay, please write down the formula first. This one don't substitute first.
Okay, Marian.
You have to write down the formula first, then only start the substitution. Okay, and then what is this? Oh, okay, you put here. Okay, I get it. Okay, and then one, then. Okay, very good. Okay, so yes, very good. Make the conclusion. Yeah, so you have to make sure that you write a proper formula first, then only start to substitute, and then start the calculation, and then get 5, and then make the conclusion. Okay, good job. Okay, be careful. Here we will lose 1 mark over here.
Okay, Marian.
Next, we proceed for question 6. Thank you, Satya. Thank you, Anwar. So question 6 is Wong and Vicky. Vicky first. Vicky. Question number 6.
Okay.
What is the important point from this question? Key point, keywords.
Line spectrum of a hydrogen atom.
Then?
Explain electronic structure of one electron system, and then a blue line in the spectrum of hydrogen atom. Transition from fourth to second shell, and what is meant by line spectrum, calculate wavelength and energy for this blue line, and state 2 Boss postulates.
So total there are how many questions for this question?
3.
3. Okay, first you have to explain what is line spectrum. Okay, based on here, right, actually you know this question is from which series? Vicky, from which series? Lyman, Balmer, Paschen, Brackett, or Kifam?
Balmer, I think.
Okay, why you think it's Balmer?
Because the electron is going to the second shell from the fourth shell.
Okay, very good. One of the point, yes, second shell. Another, if the question didn't mention about the second shell, can you identify the series for this question?
I think I can blue line.
Yes, very good, blue line, because only Balmer series can show the color of the line. Okay, very good. Okay, so you know, right, fourth line, so means this case is from n equal to, the higher energy level is n equal to 4 to n equal to 2. The transition of the electron is from n equal to 2 to 4 to 2. Let's check your answer. Okay. Let's check. Okay, so a spectrum that consists of discrete line, yes, with specific wavelength. Okay, good, acceptable. Okay, you can agree. Then number 2, energy of the blue line. Okay, try to explain your answer. First, what should you do?
First, I chose the right formula. And then I replaced the n initial and n final, and then the Rydberg constant for energy. And then I used the
What means by
calculator.
negative? What is the negative here?
Energy release. I'm sorry, I forgot to.
Yes, very good. You know, you have to write the conclusion. Okay, good, very good. Next, the question asks about
wavelength and energy for the blue line.
So you apply this formula and then get the answer.
Yep.
Okay. Okay, correct. Very good. Final answer with right unit. Okay, thank you, Vicky. Good job.
Okay.
Okay, next Wong. Okay, postulate. So there are how many postulate for both atomic structure?
I got 4.
4. Okay, so you mentioned the first one is?
The energy of an electron is quantized. But then there's the second one. The first one is the electrons move in a circular path around the nucleus of an atom, where the electrons do not absorb or radiate any energy.
Okay, so the first one, yes, move in a circular pathway around the nucleus. And then we have to mention with specific wavelength. Okay, meaning for me, the first one is not complete. For me, I write the electron move in a circular pathway, and then must mention with specific, okay, with certain wavelength. You have to mention that with certain wavelength. Okay, number 2, yes, quantize. Okay, do not radiate any energy. Okay, so be careful. Okay, when answer this kind of question, right, you just write down, okay, there are 2 postulates. So you just state, okay, the first one or the first point, number 1. You write down the full text sentences. And then number 2, you write down the full sentences. Okay, you don't need to write down the end. Okay, get it or not?
Yes, madam.
Yeah. Okay, this one you can refer to my video as well. Okay, if I want to mention another one, so tell me the number 3, number 4. Wong, continue. There are 4. So I want another answer for the third postulate and fourth postulate.
An electron at a stable state is unstable, so it will fall back to the ground state by releasing or radiating energy in the form of photon.
Okay, this is the fourth one. Okay, class have to be careful. So I repeat. The first one, right, you must mention, okay, the electron, okay, are arranged in orbit with certain radii and follow the, okay, this one circular pathway. And then number 2 is about the quantize. Number 3 is about absorb energy and then it will excited. And then the last one is about when excited state is not stable, fall back to a lower energy, release the energy in the form of photon with certain with specific wavelength and frequency. Okay, good. Okay, next question number. Thank you, Wong, and thank you, Vicky. Okay, question 7. Aisha and Aida. Aisha and Aida, your turn. Question number 7. Okay, Aida first.
Okay, soalan tu dia minta ionization energy of hydrogen atom in kg mole. So, first kita kena kira dia punya delta E.
Okay, kita tengok delta E ya. Dapat anda delta E. Okay, sambung.
Kita kena kira dia punya delta E. Lepas tu, so dia punya N initial dia 1. Dia punya N final dia adalah infinity. So kita substitute dalam formula tu. And then kita dapat jawapan dia lah 2.18 exponent negative 18 joule.
Okay, betul. So, okay, for about IE, right, we just talk about the N initial is 1 and then the N final is infinity. Okay, so this answer is standard. First of all, this is the removal. 2.18 times 10 to the power of negative 18 joule is to remove an electron. For removal of 1 more electron, you just have Avogadro, you get this answer. Don't forget the answer is 8. Unit. What is the unit, dear?
Kilojoule.
Tengok.
Pada mole.
Jadi you memang sudah hilang 1 markah. Kerana soalan memang dah insist. Memang pun dalam kilojoule per mole. Okay. So that's why ada capai akhir sini akan tolak markah dah. Be careful. Okay, for the question number 2, right? You tak jawab ikut saya. Okay, sini pun akan hilang markah. Tak apa, kita biar Aisyah tengok jawapan Aisyah. Aisyah sambung. Aisyah pun tak jawab ikut cara saya juga. Okay, Aisyah, Higgs-Boson uncertainty principle. 4 postulate contradictory means bercanggah dengan both postulate. Okay, kena. So apa yang you state kat Higgs-Boson, okay, you kena cari satu both postulate yang bercanggah dengan Higgs-Boson uncertainty. Okay, state Higgs-Boson uncertainty. Madam tak kata semasa jawab Higgs-Boson uncertainty kena buat macam mana. Hi, for my student, my dear student, I have to show the answer. Yeah. Kerana madam perasan you all tak ikut apa yang saya ajar. Apa yang saya ajar sila ikut. Kerana you tak ikut akan ditolak markah ataupun tak dapat markah penuh. Jadi adakah anda tak nak dapat markah penuh? Jadi tak nak markah penuh, jadi tak payah ikutlah. Okay. Share screen again. Try your best to do the best one. Okay. Perform. Okay. I tell you all right, when you explain right, okay, Hensable uncertainty principle, you have to mention, okay, this is the statement about Hensable uncertainty. So this one is the formula. When you show the formula, right, okay, this is the formula, you have to explain the formula as well. But your friend's answer, if you check your friend's answer, okay, they just state, didn't show the formula. Okay, so for this one, state only. Okay, if possible, right, state everything. Faham? Faham? Madam nak jawapan macam ni. Okay. So impossible to know simultaneously both the momentum and velocity, right, and the position. Kita tak tahu momentum, tak tahu position. Tapi Bose kata apa? Bose kata, okay, that electron is, yes, definitely distant from the nucleus and, okay, yes, correct answer. Okay. So this one, transfer pathway around the nucleus and electron does not. Okay, terima juga. Okay, dua jawapan pun betul. The most important point for this question, right, you must mention electron move in a circular pathway orbit around the nucleus of an atom. Okay? Satu kata, kita tak tahu lokasi dan momentum dia. Tapi Bo kata tahu, dia memang bergerak kat petala sahaja. Itulah jawapan dia. Okay, good job. Okay. Aida and Aisyah, please take note for B1. Okay. And then the unit as well. Kilojoule per mole. How about this one? Okay, very good. Yes, kilojoule per mole. Aisyah jawab dengan betul. Okay, good. Good. Okay, ini je sikit. Okay, now we proceed for question number 8. Siapa question number 8? Tak tulis nama. Okay, ni pun tak tulis. Ya. Siapa dia? Sila, okay, ni jawapan tak clear sangat. I cuba besarkan. Tak clear juga. Next time yang lepas attach sila semak jawapan memang tak clear. Ni siapa? Baca jawab soalan dulu.
Saya madam.
Nama?
Amy.
Sorry? Ellie?
Amy.
Elmi. Okay, Elmi silakan.
Okay, soalan dia. An electron of a hydrogen atom undergoes a transition to produce a line in the Paschen series with a wavelength of 1094 nanometer.
Okay, jadi Paschen series n equal to?
N equal to 3.
Okay, yang ini kita buat apa?
Tukar dalam meter.
Jadi 10 kuasa?
-9.
Kita, okay, so soalan pertama?
Soalan pertama dia suruh state region. So region dia infrared.
Okay, very good, infrared kerana dia ialah Paschen series infrared. Okay, lagi soalan 2 dia tanya apa?
Soalan 2 dia determine the energy level of the excited state. So nak kira dia pakai guna Ribet equation.
Okay, tak apa, kita sambung oleh, thank you Elmi. Kita sambung oleh ni M6T29, siapa ni?
Ni madam, Alia.
Alia, okay Alia. Jadi kita guna formula ini. Beritahu saya apa kesilapan anda?
N1 less than N2.
Yes, suppose N1, N2 and then N1 is smaller than N2. Nampak tak? Sini tadi you tulis initial final salah. Okay, so ini dah. Okay, dah. Okay, dah. Okay, kiraan. Okay, very good. So you get the N equal to 6. So class, you have to take note that you must know how to perform the calculation for the N2, N2. Okay, this one you have to shift here, shift there, move here, move there, basic mathematics, and then you make the conclusion, n equal to 6, and then the transition of electron is from, okay, yes, very good. This is the answer. Okay, thank you Alia. Nak beritahu kawan tak semasa kira ini kena berhati-hati apa? Semasa buat kiraan ini. Beritahu kawan apa yang kena berhati-hati ataupun precaution step.
Kena tahu dia punya initial energy level.
Lagi?
Lepas tu RH tu kena ingat yang formula dia 1.0 and 1.097 darat 1007.
Lagi lepas tu dia pindah kat sini ke darab ke bahagi ke macam mana?
Bahagi.
Bahagi. Okey, bagus Bahagi ya. Okey, lepas tu kat sini ialah tambah ke tolak?
Tolak.
Tolak. Okay, very good. Okay So this is a basic mathematical calculation. Thank you Alia. Okay, next question number 9. Hana, and then this one, who is question number 9 for M6?
Me, Madam Aziana.
Aliana dan Hana. Okay. Aliana dan Hana. Aliana dulu. Question number 9. Then now start.
Calculate the first 3 wavelength of the possible transition of an electron in the Paschen series for a hydrogen atom. And show
the first 3 line. Okay, show. Show apa? Wavelength.
Of line spectrum.
Sketch. Line spectrum. Line spectrum Yang lagi apa?
Explain how this
explain. Okay, jadi dari soalan ni apa yang Aliana kena tahu?
The value for the first 3 wavelength in the Paschen series.
What sikit, sorry? Paschen N sama dengan berapa?
N equal to 3.
N equal to 3. Okay. So first 3 wavelength maksudnya dari mana ke mana?
4, 5, 6. F.
5? Okay. 4, okay, faham. 4, 5, 6 ke 3. Ya, dia tengok jawapan anda. Okay, tengok. Betul tak? Okay, yes, you are the sekali lagi, apa silapan anda?
N1 less than N2.
Yeah. So, but you very good. You stick 4, 5, 6. Okay, lepas tu kira-kira. Okay. Semua orang tengok betul tak apa yang dia kira tu? 1.8752. Yes. 1.28. Okay. Yes. Yes. Okay, betul. Okay. Lepas tu yang ini tak nampak sangat. Madam tengok pesta dan boleh tak? So, okay, kita tahu, okay, gambar raja macam betul dah. Okay, kena tambah sikit. Okay, which one is the first line? So this is the first line, second line, third line. So meaning that you have to show that this is what happened. Okay, increasing of wavelength. Okay, kena gunakan increasing of wavelength. Ataupun ini songsang dan boleh. Okay, terima kasih. Next, kita tengok yang ni. Pun sama. Jawapan semua betul. Pun sama yang ni tak tunjuk increasing wavelength. Okay, cuma everybody please please compare. Nampak tak perbezaan dia? Yang ni first line dia kat sini. Jawapan ini first line dia kat sini. Boleh je tak kisah. Tak kisah. Kanan ke kiri, kiri ke kanan pun boleh. Okay, janji label betul. Okay, so increasing wavelength dia macam ni lah. Macam ni lah, tulis increasing wavelength. Increasing wavelength. Tuliskan ha. Kerana yang soalan Hana dia buat jawapan semakin first line is here. So jadi increasing wavelength dia macam tu. Yang Iliana dia macam ni, dia first line kat sini, jadi increasing wavelength dia macam tu. Okay ya, depends on you. Dari left to right ke right to left, boleh je. Okay, jadi sendiri kena clear. Okay, Hana, okay, question number, this one, explain how this transition occur.
The electron at the excited state, such as n equal to 4, is unstable and will fall to the lower energy level.
N equal to?
N equal to 3.
Okay, continue. Then what happened?
A specific amount of energy is released in the form of proton during the transition of electron.
And then will form how many lines? Appear as how many lines? 4 to 4. Dia akan muncul berapa garis?
Or 3.
3. So which appear as 3 line in the emission spectrum. Tambah sikit. Okay, good. Okay. Semua orang alert So dia ada beritahu for mengapa 4 sahaja? Sepatutnya 4, 5, 6 Okay, you can bracket excited state n equal to 4, n equal to 5, n equal to 6 Here.
Okay.
Equal to 5, n equal to 6 kerana involve 3 line. Okay, so unstable for, okay, here n equal to 3, okay, appear as 3 line As 3 line in the emission spectrum. Okay, so kita tengok jawapan sini macam mana pula. Oh, tak ada penerangan, ada tak? Oh, ni tak ada penerangan Okay, tak apa. Next, question number 10. Okay, whose turn? Yang belakang tu siapa tak tulis nama, sila tulis nama sekarang Okay. Question number 10. Siapa dia?
Baria.
Okay, Baria. Okay, Baria. M7 ke M6?
M6.
Okay, soalan ni. Okay, biar Baria start dulu Baria. Question 10.
First question. Dia tanya perbezaan antara ground state and excited state of an electron in an atom.
Jadi apa perbezaan dia? Wow. Ini jawapan anda. Panjangnya. Okay, cuba tengok. Nampak ke tak? Saya nak besarkan lagi supaya semua orang nampak. So, jawapan anda. Ground state apa keywords dia?
Ground state is state where electron system are in lowest possible energy levels.
Okay, lepas tu?
Excited state, system that the electron have shift from a lower energy level to a higher energy level.
Okay. Boleh terima. Actually, you can mention ground state is lowest and then excited state is higher than ground state. Also can Okay, second point. Lagi satu key point sebab last week memang ada beritahu. Ground state you must mention most stable. And then excited state unstable. Okay So class you have to alert you have to mention ground state lowest energy level. Okay, and then excited state is higher than ground state or higher than which the electron stay Another point is about stability. Most stable, unstable. Okay, good. Next, B. Okay, B. Sambung dulu. Raya sambung. Okay, B dia tanya apa pula?
Dia tanya energy of the electron at the excited level dengan energy emit as the result of the transition.
So dari sini apa yang you tahu?
Kita tahu N equal to 3.
3. Okay. So dia nak kira apa?
Kilojoule mole per mole.
Okay, untuk energi ya.
Ah.
Okay, lepas tu dia nak tentukan apa?
Tentukan yang paling pendek.
Paling pendek. Okay. In specific nanometer. This question nanometer. Okay, thank you Braya. Okay, siapa dia lagi seorang?
Farah.
Okay, Farah. Okay, Farah, kita tengok kiraan anda. Okay. Silakan anda. Okay, Madam perasan kan ramai tengok ada. Mengapa tak buat kat tepi? Terus buat kat tepi je.
Okay, Madam.
Okay ya, yang ni terus buat kat tepi je. Tulis kat tepi, terus buat kat sini je. Okay. Soalan yang pertama dia tanya, macam kurang tepat je. Okay. Kita tengok jawapan ni pula. Macam tak jawab soalan ha? Okay, ini jawab tapi kurang lengkap juga. Unit. Braya, unit kat mana? Basha, unit tak tulis. Okay, kemudian formula pun salah. Siapa boleh tahu saya formula dia salah kat mana? Class? Anyone?
Negatif.
Yes, negatif. Okay, negatif. Kiraan dia betul. Kemudian dia tak tulis unit pula. So this one is negative. So suppose is negative, and then with Joe. Yang sini dia terus memang salah. Okay, kira memang salah. Tak faham soalan. Okay, sorry ya, siapa? M7, siapa ni? Farah. Okay, Farah, cuba tengok semula soalan. Soalan nak tanya apa? Kerana jawapan you kurang tepat. Okay, so tengok sekarang ayat you baca betul-betul. Calculate apa? Dia nak apa? You cuba bacakan. Calculate.
Kilojoule.
Faham kan soalan dulu? Adakah ada kilojoule mole? Dia nak unit kilojoule mole. Kilojoule per mole. Dia nak kira apa? Farah kira. Adakah dia suruh you kira delta E? Hanya ataupun dia nak suruh you kira energy of the electron at the excited state sahaja?
So dia energy.
Tengok soalan yang kena kira transition, you tengok apa yang dia tanya. Nampak tak? Calculate the energy of the photon emitted. Okay, the photon emitted. Photon macam mana boleh emitted from a higher to lower. Okay, and then calculate the radiation of the radiation ataupun guna perkataan radiation. Okay, baru akan evolve transition. Okay, berapa ke berapa. Tapi untuk yang ini, dia hanya nak excited state sahaja, excited level sahaja. Maksudnya excited level dia berapa? N equal 6. Maksudnya dia hanya nak kira E6 sahaja. Okay. Lepas tu, and the energy emitted as the result, okay, of the transition. Okay, nak energy dia kena darab constant, Avogadro constant. So that's why jawapan anda kurang tepat. And then jawapan Barsha, okay, formula betul. Okay, formula salah. Okay, dia nak kira E6. Okay, nilai dia betul. Tapi dia tak tulis negatif. Atas sebab tu dia salah. Okay, tapi dia belum siap lagi. Kerana dia nak kira energy of an electron in 1 mole. That's why this value you have to continue times number of Avogadro. Anything that kilojoule per mole means the question asks you to calculate the energy released for 1 mole of electron. So for this case, 1 mole of electron based on E6. Once you get negative 6.056 times 10 to the power of negative 20 joule, right? Is it correct? Yes, negative 20 joule. You have to times Avogadro constant, and then you get 36.45 kilojoule per mole. Okay, please take note. Semua orang sambung. So this is the first part, and then followed by second part times number of Avogadro. Okay, baru jawab soalan yang part 1. Okay, lepas tu soalan sambung lagi. Sambung lagi. Dia belum siap lagi. Kan dia ada N. Okay, the energy emitted as the result of the transition. Nampak perkataan transition? So, barulah, okay, apa yang you buat? Farah sambung. Okay, Farah yang buat ni barulah untuk part 2. Okay. So, Farah dapat, Farah you ni kat mana? Makan sangat banyak ke? Nak bagi saja kan? Tapi macam kiraan pun ada masalah juga. Oh, you bukan kira delta E. Oh, delta E kat bawah. Biar aku tengok. Oh, you kira lambda, lepas tu sambung delta E. Okay, delta E dapat 1.8169 darab 10 kuasa. Okay. Kilojoule. Negatif 22 kilojoule. Okay, lepas tu sama juga. Dia nak kilojoule per mole. Kat sini you kena darab Avogadro constant juga. Okay, kat sini kena darab Avogadro constant juga. Ni soalan 10 ni soalan yang tough sikit . This one is a tough question. I think many students will start. PSPM 1617. Okay. So, okay. Yang ini ada buat ke tak? Oh, yang ni Prasha tak buat. Okay, madam ulang sekali lagi . Difference should be no problem. Okay. So for this one, this part no problem, settle. Second part, okay, identify no problem. Okay, this is the first question. And then this one is the second question. Okay, this one is the third question. And then this one is the fourth question. So for 2 and 3, okay, 2 you need to calculate the E6. 1 you success the E6, right? Then followed by the E6 times number of Avogadro. Okay, number 3, right, you have to show the transition. Transition is here, N6 to N3. So you are going to use the delta E. Okay, you are going to use the delta E equal to RH, equal to RH 1 over N initial square minus 1 over N final square. After you get the delta E, right, okay, you get the first part, and then the delta E that you get, right, you need to times Avogadro constant as well, because the question asks about calculate in kilojoule per mole. You need the energy released for 1 mole of the electron. Okay, boleh faham? Okay, so E6, right, the first part you will get the answer negative 6.056 times 10 to the power of negative 20 joule. And then after times the number of Avogadro, right, okay, and then convert to kilojoule, you will get 36.45 kilojoule per mole. Okay, and then for this part, okay, the transition of the the electron between these two energy level, you will get negative 1.817 times 10 to the power of negative 19 joule. After times Avogadro and then convert to kilojoule, you get 109.36 kilojoule per mole. Clear? Clear?
Yes.
Okay. Now, okay, part 4. Haven't settled yet. Okay, part 4. Determine the shortest wavelength. Shortest wavelength means highest delta E. How to achieve highest delta E? When n equal to?
Infinity.
Yes, very good. When n equal to infinity. That's why this one is Paschen series. Paschen, right? Is it Paschen or Paschen series? Okay, meaning that the n initial is 3 and then the n final is infinity. Okay, so in this case, the question asks about shortest wavelength. Determine the shortest wavelength. So meaning that we need to calculate the wavelength and then convert into nanometer. So let's check. Is there any answer from your friends? Tak ada. Here pun tak ada. Okay. Mengapa ada line D? Soalan ni tak ada line A, B, C pun kan? Tak ada. So you jangan bagi sendiri buat line D ya. Jadi silap juga ah. Tak boleh ya. Okay. So in this case, right? Infinity ya. Infinity. How to? I need to open. Okay. Okay, here. That's for the part 4. For the part 4, right, so I need to apply the formula 1 over lambda equal to RH 1 over n1 square minus 1 over n2 square. And then remember, I noticed many of you, I think 80% of you forget to write down this one. Okay, then substitute. So substitute everything, you get 121 888.89 per meter. So this is the wave number, the value of the wave number. Then you go to try to find out the lambda, and then you convert to nanometer, and then you get the answer 820.4 nanometer. Okay, so this is question number 10. Okay, later I will ask you, all right, okay, to share the answer question number 10 for me. Okay, it's a tough question. Okay, now we proceed with question number 11. Who's turn? Okay, still got 4 questions. Question number 11. Siapa dia? Okay, jelas. Shida. Lagi.
Yes, madam.
Fatin.
Ya, madam.
Okay, Fatin dulu. Fatin, analyze the question. Dia nak buat apa?
Sketch the energy level diagram to show the electronic transition which give rise to the first five lines in Lyman series.
Okay, jom tengok jawapan anda. Terangkan.
Okay, Lyman series n equal to 1. So first 5, 1, 2, 3, 4, 5.
Cuba terangkan file line tu macam mana terhasil.
And 1
cakap je dia macam
is
mana
the longer
sayang
distance.
Fatin. You kena cakap
Yeah.
macam ni.
Oh, okay. Hydrogen atom possesses the properties of energy of when the electron of a hydrogen atom during its ground state transits to a higher energy level excited state.
Okay, and then
at excited state, the electrons are actually unstable and tend to fall back to the ground state. That is 10 equal to 1.
Okay, lagi.
During this transition of electron, the radiant energy emitted in the form of photon or light.
Okay, with specific wavelength, specific frequency, semua kena tulis Kemudian yang produce kat ultraviolet region kerana dia Lyman series. Okay, betul lah. Okay kita kali keempat pinjam benda ni And then 5 line means from 2 to 1, 3 to 1, 4 to 1, 5 to 1 and 6 to 1 Okay, satu benda tak label. Sini kena label Lyman series. Kat bawah sini kena label Lyman series Tengok yang ini label ke tak? Pun tak label. Okay, semua orang label, make sure For the n equal to 1, right, all drop to alignment series. So you just label here alignment series. Okay, explanation okay, good. Okay, next. Aisyah, sambung yang, Syida, sambung yang second part. Terima kasih. Terima kasih, Fatin. Okay, Aisyah, sambung second part.
Second part.
Macam lebih kurang sama je, you tengok sini. Kotak 3 ni lebih kurang sama je. Sepatutnya dia macam mana? Yang ini? Okay, this one yes. This one okay. Nampak tak? Jawapan Fatin okay. Tapi jawapan Syida kurang okay. Dah mengapa? Syida, dah mengapa?
Jarak dia.
Jarak dia kena macam ni ya. Cuba tengok So, okay madam. Syida, madam guna jawapan Fatin, you beritahu saya. Antara ni A. Okay, I tak apa tiba-tiba aku tak boleh tulis. Okay. I refresh sekejap I nak tanya you yang mana ialah first line. Okay. Lepas tu kena beritahu saya dari kanan ke kiri ataupun kiri ke kanan apa yang berlaku terhadap wavelength and frequency. Tiba-tiba dia tak nak bergerak pula. Tunggu sekejap Everybody stay focused. There are another 3 questions very fun only. Okay, dah. So harap aku dapat edit. Okay, so madam label ini A lah, B lah, C, D, E. Okay, which one is the first line? A, very good. So A have the shortest frequency. Okay, I label macam ni. Okay, sekarang dia buat macam ni. Increasing frequency. Okay, betul. So sini increasing wavelength. Okay, so line A. Line A maksudnya kat sini. Ini adalah line A. So from n equal to 2 to n equal to 1. So what happened to the lambda? Lambda is the largest one. And then delta E is the smallest one. So frequency is the, okay, smallest as well. So that's why you all kena clear tentang macam ni. That's why. So dari kanan ke kiri, wavelength increase. Dari kiri ke kanan, frequency increase. Jadi jawapan Fatin memang betul lah. Boleh faham?
Boleh.
Boleh Okay. Thank you Fatin and thank you Syida. So next we proceed for question number 12. Firza. Ni siapa? Tak nampak. Lagi tak nampak kalau ada macam ni. Ni siapa dia? Ding ding ding. Oh, Aisyah. Aisyah? Dipersilakan. Okey, kita tengok soalan 12. Apa soalan 12 tanya?
Determine the transition that forms the B line. So kita kena cari energy level final for B line. So kita guna formula 1 over lambda sama dengan RH dalam bracket 1 per N1 kuasa 2 tolak dengan 1 per N2 kuasa 2 sama dengan N kecil, N smaller than N.
Betul. Tapi sebelum start kan kita kena tahu bracket N sama dengan berapa?
4.
Okay, kita kena tahu N sama dengan 4. Lepas tu kita kena buat apa terhadap sini? Convert. Jadi apa? Nanometer kena jadi convert 10 to the power of negative 9. Okay, so nak tanya bracket N1 ke N2? Bracket N1 ke N2? Plus bracket N1 ke N2?
N1.
Yes, N1. Hanya Lin yang jawab kan? Semua orang semasa jawab soalan ni kan, you kena clear. N1 ke N2 because bracket is the final line. Dia jatuh kat bracket. Maksudnya bracket dia akan kecil because the electron drop. So this is N equal to 4. So meaning that from higher. Okay, this one highest is N2. N2 must be larger than N1. This is N2, this is N1. So N2 must be larger. So we do know what is the value of N2. That's why we perform the calculation by using this formula. Okay, formula yang dia pakai tu betul ah. So sekarang semua tahu kan, kena pandai main matematik ya. Kat sini kira yes, N equal to 6, the energy level okay. Excited is N equal to 7. So conclusion jangan buat macam ni. Conclusion buat ayat lengkap. The electron make a transition from N equal to 7 to N equal to 4. Aisyah, boleh?
Boleh, madam.
Okay, part 1 betul. Okay, jom kita tengok yang Fiuza punya. Okay, Fiuza pun betul tapi Fiuza tak buat conclusion ah. Okay, sambung oleh Fiuza. Fiuza part 2 kena buat apa?
Part 2 dia minta pada cari change of energy. So kat sini kita pakai formula C over lambda. Dan lepas substitute H, C and lambda akan dapat 9.18 times 10 to the power of negative 20 joule.
Okay, betul. Okay, terus pakai H, C over lambda. Ada formula lain ke tak? Ada formula lain boleh pakai ke tak? Kita tengok yang ni. Ni formula dia. Okay, there are two methods ah. One is using delta E by using the Rabbit constant. Another one is using delta E HC over lambda. But you still get the same answer. Very good. Okay. Ni pun sama, dapat jawapan akhir tak? Okay, sama, betul. Okay, Fiuza, C. A3. A3 tanya apa pula?
A3 dia ada line wavelength yang smaller. So dia tanya nak explain by qualitatively whether line B or line C tu has higher energy emitted. So by using the formula delta E equals to HC over lambda, it is obvious that kalau change of energy dia tinggi, dia punya lambda akan jadi rendah. So in this case, the shorter the wavelength, the higher the energy emitted. So thus the conclusion is line C has shorter wavelength than line B.
Okay, very good. Okay. Apa yang Fiuza terang tu betul, dia apply formula ini. Warna merah supaya orang nampak sikit. So you try to apply this formula. Delta E equal to HC over lambda. So what happened? When delta E increase, right? Okay, and then lambda decrease. So the shorter wavelength, the higher the delta E emitted. So that's why C emitted higher energy. And then shortest wavelength, did you mention? Yes, line C shortest wavelength compared to line B. Line C emitted higher energy compared to line B. Okay, okay, good. So this one is the answer. Okay, please jot down semua orang sila jot down jawapan dia. Okay, madam besarkan sikit lagi. Ini penerangan dia. Okay, kalau saya besarkan, arrow saya pun ni lah, this part. Okay, now we proceed with question number 12. 13. Okay, 13. Next. Okay. Okay, Faleha. Siapa ni? Faleha dulu. Okay, soalan 13 apa yang kena tahu?
Okay, the line spectrum of hydrogen.
Okay, the line spectrum of
hydrogen atom in the visible region is shown in the following diagram. Visible region is for Balmer series.
Yes, very good. N equal to?
N equals to 2.
Okay, you can continue.
Okay, the first question is asked, name the series of the line spectrum. So the series is Balmer series.
Okay, good. Then second question.
Sketch an energy level diagram of a hydrogen atom for the formation of line X. Explain how line X is formed. Line X is the second line of the Balmer series from the transition of N equals to 4 to N equals to 2.
Yes, very good. N equal to 4 to N equal to 2. So please take note, this is the first line. 3, 2. Okay, from n equal to 2 to n3 to n equal to 2. Okay, very good. So you get the answer. Let's check your drawing, because the question asked about draw. Oh, okay, you draw everything. Actually, no need, class, because the question just asked about line X only, right? You just need to show this one. Okay, and then where is your y-axis? And then, yeah, okay, here, okay, no problem. Let's check for another answer and see. Ini salah juga.
Salah.
Apa yang salah? Beritahu saya.
Saya buat Lyman.
You buat Lyman. Bukan? Lyman salah juga. Lagi? Second line, right? Tapi you tadi line berapa? Obviously menunjukkan anda tak faham soalan. Lagi satu yang sangat penting, I keep on emphasize. Your drawing, the energy level. You tengok jawapan ini dan bandingkan dengan jawapan anda. Apakah yang silap? Siapa ni ya? M7? Intan. Okay, Intan. Intan, apa yang silap kat sini? You tengok jawapan dia, jawapan ini. Dan banding jawapan anda. Megan ada beritahu.
Garisannya.
Garisan yang macam mana?
Yang n equal to 1, n equal to 2.
Yang macam mana? N equal to 1, n equal to 2 yang macam mana? Keywords you tak keluar lagi. Intan?
Yes.
Keywords tak keluar lagi. Apa ni? Saya sedang tunjukkan. Beritahu saya. Kata kunci apa?
Energy level.
Ya, energy level. Kemudian sila describe sikit. Semakin macam mana? Kena semakin?
Kecil.
Kecil, yes. Okay. So the distance between the two energy level when you draw it, right, getting closer or getting narrow. Okay. Tapi you tengok sama rata je. You boleh sama rata, tak boleh ya. And lagi dia memang kena kat n equal to 2. Kemudian second line 2 je. Satu line, 2 line. So dari 2 kali je melibatkan 2 energy level je. Tapi you melibatkan berapa energy level? Mereka tak tahu dah. Okay. Memang tak dapat makan langsung. Okay. Tapi you label y-axis lah. Okay. You label x. So for this one label x but forward the y-axis lah. Okay. So I hope you all can get it lah. And then just now Faliha already explained. Okay. This is the line. Formation of line X. Okay, we check form electron make a transition. Okay. Okay lah, boleh terima. Okay, next calculation. Calculation Intan, calculation macam mana? Part tu nak buat macam mana? Calculate. Nak kira apa? Okay, line X. Jadi line X you tahu 4 ke 2 ke tak? Silap.
Silap.
Memang silap semua. Okay, sini silap, yang sini pun akan silap. Nampak tak? Okay, kelas semua kena ingat impact untuk chapter 2 kan. Kalau kira starting salah, yang bawah ni semua salah. Okay ya, so jom kita tengok jawapan Faliha. Faliha betul ke tak? Okay. Formula, yes, correct. But still the same. That's why I cakap 90% bukan 80% dah. Tak tulis. Kena tulis Okay. And then the unit here is per meter. So 4.86. And 10 to the power of 7. Yes, okay. Number 4. 4 dia nak apa? Intan 4 dia nak apa? Energy. So meaning that based on question number 13A3, continue to get this one. Mengapa tak kira? Faleha pun silap. Faleha kena kira. Okay. So apa formula yang kena pakai Intan ataupun Faleha?
Delta E equal to
Delta E yang mana? HC over H boleh ke dapat ke delta E equal to H mu atau mu ke? mu pun tak beri, tak boleh. Kalau delta E equal to HC over lambda, frequency pun tak bagi, macam mana nak kira? So that's why there is only one formula can apply for this question. Formula yang mana? Delta E equal to RH 1 over initial square minus 1 over final square sahaja. Okay, you will get the answer negative 4.09 times 10 to the power of negative 19 joule. Don't forget to make the conclusion. The energy released is 4.09 times 10 to the power of negative 19 joule. Please take note. So question 3 Faleha betul, tapi question 4 Faleha tak kira energy. Soalan nak kira, baca soalan betul-betul. Dia nak determine, okay, kalau nak determine energy involved kan, memang kena buat kiraan lah. Okay ya. Walaupun dia tak tulis calculate, tapi determine lagi higher level compared to calculate. So maksudnya you kena kira, okay, dapat energy dia. Okay, last question. Question 14. Whose turn? Najihah and Katiani. Okay, Najihah first. Soalan apa? Najihah?
The energy emitted and the wavelength of the spectrum line when an electron moves from n equal to n to n equal to 3.
Okay, stop. Kat sini ada berapa soalan?
2.
So, one is energy emitted. Nampak tak? Kalau energy emitted, energy release, okay, the transition, baru kita akan guna delta E ya. Kemudian state ya. Wavelength akan guna delta E equal to H mu over lambda. Boleh ke tak boleh? Mu tak ada. So, kita akan, ataupun lagi apa? Ini satu formula. Saya tak ingat dah. Tiba-tiba start. Lambda equal to T mu. Okay, tak boleh. Memang kena guna 1 over lambda dulu and delta E 1 over, okay, kita tengok jawapan lah. Okay, so tengok. Okay, betul delta E guna. Okay, betul. Betul tak kelas? Negative 1.82 times 10 to the power of negative 19 joule. Okay, yang ini madam nak beritahu delta E sama dengan HC over lambda. Okay, yes, Planck constant, yes, yang ini madam nak beritahu. Okay, tak berjawapan betul. Okay, ataupun tengok Katiani punya, betul tak? Katiani guna ni. Okay, dia kira delta E dulu, lepas tu guna yang ni pun boleh ya. Okay, part 2. Both of them giving this different solution, different formula, but they still give the same answer. Okay, 4.343 times 10 to the power of negative 7. Okay. Tak. Why? Jawapan berbeza. Siapa yang betul? Nanti yang ni betul. Okay, ni betul. Final answer correct. This one correct. How about this one? Jawapan anda salah. Najihah, jawapan salah. Salah kat mana pula? Jom sama-sama kita tengok. Najihah salah kat mana? Jawapan Khatijah ni betul. Tapi jawapan akhir Khatijah, Najihah bersalah. Semua orang tengok dia salah kat mana. Semua orang keluarkan tekan calculator. Let's check. Okay, this is answer for Khatiyani. Okay, delta E correct. 1.82 times 10 to the power of negative 19. Here also the same 1.82 times 10 to the power of negative 19. But we proceed, right? We want to find the lambda, right? The second part is wavelength lambda. So Khatiyani by using the 1 over lambda to proceed to get the answer, which is 1.094 times 10 to the power of negative 6 meter. But why Najihah cannot get the same answer? By right, she can get the same answer. Semua orang sila tekan calculator. Najihah tekan semula. Okay, kita kena tahu because sometimes you're not sure which formula you are going to use. So you must know why. Suppose you get the same answer.
Madam, saya rasa Najia salah tulis jawapan.
You salah tulis jawapan.
Yes, kalau tekan calculator dapat.
Yes, madam pun pelik. Budak saya pandai. Substitution betul tapi jawapan salah. Dari
Alah,
sini,
medium.
dari sini you tahu saya
Sorry,
tahu
medium.
apa? I tahu you mungkin salin jawapan dari kawan kot. Hehehe. Buat sendiri ke tak? Atau rujuk kawan punya jawapan?
Bukan, saya ada rujuk nota kot. So, terambil jawapan nota tu.
I see. Okay, be careful So, macam pelik. Okay, ni betul. Jawapan dia silap. Okay, kerana salin jawapan buku. Okay. So, the last question infrared. Okay, betul. Yang ini pun betul. Okay, katanya ni tak sempat nak present. Okay, so kita habis untuk perbincangan 2.1. So, okay, 2. So, I will stop here first. Okay. Stop presenting, stop recording.
Thanks for watching. Please do remember, subscribe my channel and follow my IG, TikTok and Facebook. See you all again on next video. Bye!